Hello, these are some notes to help you as you're studying for your Chapter 5 test. And first of all, the first problem is this. 5x cubed minus 5x to the fourth plus 7. Now, first of all, let's look at the term, the 5x cubed term. And the coefficient of that term is equal to 5, right? The degree of it is the power, which is 3. And then now let's look at the negative 5x to the fourth term. And the coefficient is equal to negative 5. And the degree is equal to 4 of that. Now let's look at the, I just realized I made a mistake. I left part of the problem out. It actually says negative x plus 7. And then the negative x term, what's the coefficient? The coefficient of that term is the number in front of the x, which is negative 1. And the degree of it is the power of the x, and it doesn't really have a visible power, so that means the power of it is 1, so the degree of it is 1. Now the 7, the coefficient of 7 is just 7. And the degree of the term 7, now the number 7 has a power of 1, but that's actually not what the degree is. You see there's no x beside the 7. The degree is how many powers you have of x, and there is no x, so the degree is 0. Now, what's the degree of the whole polynomial? So the degree of the whole polynomial is the highest degree of them all, because the highest power of them all is the highest power that the polynomial has. So the degree of the polynomial is 4, because that's the highest power that it has in all of its terms, and among all of its terms. And then the leading term of the polynomial is the term that had the highest degree, which would equal the negative 5x to the fourth term. And the leading coefficient is the coefficient of the leading term. So the leading coefficient is negative 5. Perfect. Now, let's try problem 2. So this polynomial is x squared y squared minus 6x cubed y to the fifth plus 4y squared minus 9. So the coefficient of the first term, the coefficient is equal to 1, and the degree of the first term, so the coefficient equals 1. The degree of the first term is how many powers it has, but it has 2 different powers of 2, so that's a total of 4. So the degree of the first term is 4. Now let's look at the second term. The coefficient of the second term is negative 6. The degree of the second term, the degree of the second term is how many powers it has. It has a total of 8 powers. Then let's look at the third term. The coefficient of the third term is 4. The degree of the third term equals 2. Then let's look at the fourth term. The coefficient of the fourth term is negative 9, and the degree of it is 0, because there's no letters beside it. And then the degree of the whole polynomial, so what's the degree of the whole thing, the whole polynomial? The degree of the whole thing is the highest degree, which is 8. And the leading term is the term of it that had the highest degree. So the leading term is the term that had the 8 letters in it, so it would be negative 6x cubed y to the fifth. And the leading coefficient is the coefficient of the leading term, which is negative 6. Perfect. Now let's try problem 3. So the problem 3 says 3x cubed minus 3x squared plus 8x plus 4. Find g of negative 2. And since g of x equals that, g of negative 2 therefore represents the same thing copied in a carbon copy, except with negative 2 plugged in for x. So it'll be that. And then negative 2 to the third power is negative 8. Negative 2 squared is positive 4. 8 times negative 2 is negative 16. Then you keep going. You get negative 24 minus 12 minus 16 plus 4. So negative 24 minus 12 is negative 36 minus 16 plus 4. So negative 16 plus 4 is negative 12. And negative 36 minus 12 equals negative 48. Now let's try problem 4. So problem 4 says 7x cubed minus 4x squared plus 7x minus 2. Find f of 0. So if that's f of x, then f of 0 just means plug in 0. But see, if you plug in 0 into all of those x's, they'll all just be zeros. So you'll just have 0, 0, 0, minus 2. So the answer is just negative 2. Now let's try problem 5. So it says f of x equals negative 4x squared plus 4x plus 3. And we're supposed to graph it. So the leading term is the one with the biggest power, right? And the leading term is negative, so you know the right side of it goes downwards. And also, the degree of the leading term is even, right? It's even because it's okay, so the degree of it is 2, right? Because that is a power of 2. But 2 is an even number. So an even degree in a polynomial means that the behavior on the left of the graph is going to be the same as the behavior on the right. So if the right goes down, like this one does, then the left side would also go down. Or if the right went up, then the left would also go up. But since our right side goes down, then our left side will go down because even means both sides do the same thing as each other. Well, now we'll just fill in the rest of the graph. Sorry, that's not very accurate. And so it looks kind of like that. So you'll just pick the graph that looks like it's going, for this problem at least, looking the same on both sides because it's an even degree. And it's going down on the right side because it has a negative leading term. Now problem 6, that just says negative 7x cubed y z times 5x to the 5th y z to the 5th. Negative 7x to the 3rd y z, 5x to the 5th y z to the 5th. So that equals negative 35x. Okay, there's 3 and 5, that makes 8. Then there's y times y is y squared. Z times z to the 5th, that makes a power of 6, because we have 1z plus 5 to the power of 6. So that's that one. And then let's try number 7. So x minus y, x squared minus 6xy plus y squared. So x times x squared equals x cubed. X times negative 6xy equals negative 6x squared y. X times y squared is just xy squared. Then we'll go to the negative y. So negative y times x squared is negative yx squared. Negative y times negative 6xy is negative 6xy squared. Then go to the last term. Negative y times y squared is negative y to the 3rd. And then we'll add them up. We'll get x cubed Now that's actually the same because this has a yx squared and a y and an x squared y. So we can add them together and get -7. We could say yx squared or x squared y. I guess I'll just say x squared y. And then we have +1 xy squared and -6 xy squared. So that leaves us with -5 xy squared, then minus y cubed. So we're done with that one. Then problem 8. X minus 5y times 2x plus 3y. So we're going to use the FOIL method, which means first that times that is 2x squared, and then outside, which means that times that, so that'd be plus 3xy, and then inside, this one times this one, that would be -10 yx or xy, it doesn't matter. And then last, it would be this one times this one. That would be -15 y squared. So add those up and you get 2x squared minus 7xy minus 15y squared. Done. And then we have problem number 9. Oh, and then that's the result. Then we have problem number 9. X minus 6 squared. It says multiply using the rule for the square of a binomial. So the square of a binomial is you square the first one, and then you distribute this 2 times this times this. So we do 2ab. So 2 times -6 equals -12. But -12 times x is just -12x. So 2ab just means 2 times -6, which makes 12, times x, which makes -12x, plus b squared. So b is -6. If you do -6 squared, that's -6 times -6, which is +36. So that's the answer. Then we have problem 10. 7x plus 4y times 7x minus 4y. Now notice those are almost the same problem. So it's the sum and the difference of the same two terms. So that when that happens, you just have to do the first and the last. So that's 49x squared, and then the last one is -16y squared. Then we have number 11, which, oh wait, let me go to a new page. And now we're on problem number 11. It says find the product 3x plus 2 plus 3y multiplied by 3x plus 2 minus 3y. So this is the sum and difference of the same two terms. So we only need to multiply the first times the first, 3x plus 2 times 3x plus 2, which is 3x plus 2 squared, and the last times the last, which is -9y squared. Then we can use the formula for the square of a binomial. So we'll square the first term and get 9x squared. Then we'll distribute this 2. 2 times 2 is 4. And then you do 4 times 3x and you get 12x. Then we're going to square the last term. 2 squared equals 4. Then we're going to bring down the -9y squared. And then that's all the answer. So that's it. Okay, now let's try to do number 12. So f of x equals f of x equals x minus 4, and g of x equals x plus 3. So what's f times g of x? So if I multiply them together, that's called f times g of x. So I'll FOIL that, and I'll get first, and then outside, inside, and last. And then I'll add the like terms together. I'll get x squared minus x minus 12. So that's the first answer. Then it also wants to find what's fg of negative 3. So the best way to do that is to plug in negative 3 into this. If you plug in negative 3 into that, you get that. Then also plug negative 3 into g. If you plug negative 3 into g, you'll get negative 3 plus 3, which negative 3 minus 4 is negative 7. And then negative 3 plus 3 is 0, so you get negative 7 times 0, which is equal to 0. Then let's try fg of 0. So fg of 0, the best way to do that is, okay, let's plug 0 into f of x, which is 0 minus 4. Plug 0 into g of x, which is 0 plus 3. And then you get negative 4 times positive 3, which equals negative 12. So that was that. That was not too bad. All right, let's try to do problem 13. So problem 13 says f of x equals x squared minus 7x plus 3. What is f of a plus 2? So you replace the x with an a plus 2 and replace the next x with an a plus 2, and then you do that. So if you if you square a binomial, you'll square the first one, then you'll distribute this power of 2. 2 times 2 is 4, times a is 4a. Then you square the last one, you get 2 squared is 4. Then you distribute this negative 7, you get negative 7a. Then you do that times that, you get negative 14. Then you bring down the plus 3. So now you combine the like terms and you'll get a squared minus 3a. 4 minus 14 is negative 10. Negative 10 plus 3 is negative 7. So a squared minus 3a minus 7. That's the answer. And then next, part B, it says find f of a plus h minus f of a. So that's actually two problems in one. So first of all, I'm going to find f of a plus h. That would equal a plus h squared minus 7 times a plus h plus 3. And then the second part of the problem is minus f of a, which is a squared minus 7a plus 3. And make sure that you put the a squared minus 7a plus 3 inside of parentheses, and then make sure that negative is in front of those parentheses. Okay, well now, let's square this binomial. So if we square the first term, it'll be a squared. If we distribute the 2, it'll be 2ah, or 2a. H squared is h squared. Then distribute the negative 7, negative 7a and negative 7h. Keep the plus 3, then distribute the negative sign. Negative times positive is negative. Negative times negative is positive 7a. Negative times positive is negative 3. And then watch this. That negative 3 crosses the positive 3 out. The 7a crosses out the negative 7a. And the negative a squared crosses out the positive a squared. So the only thing left in the answer is just 2 plus h squared minus 7h. So there we go. Perfect. Now let's go to problem 14. Two x cubed plus 8x squared. Factor out the greatest common factor. So a 2 can come out of both of those, and also x to the power of 2 can come out of both of them as well. Now what times 2x squared would leave you with 2x cubed? It would be an x. And then what times 2x squared would make 8x squared? It would be 4, right? So you're basically backwards multiplying it when you're factoring it. So 4 times 2x squared leaves you with 8x squared, so that's what you would do. So that's the answer. That wasn't too bad. Then 15, it's a similar thing. So 15 says 77xy minus 56, x to the 8th, y to the 8th, minus 70x to the 8th, y to the 5th. So factor the greatest common factor. Well, you could factor out a 7 from everything, and an x from everything, and a y from everything. If you did that, you'd be left with 11, because 7 times 11 is 77, and then minus 8, because 8 times 7 is 56, and then you'd have x to the 7th left over because you took one of them out. You'd have y to the 7th left over, you'd have negative 10 left over, you'd have x to the 7th left over, and y to the 4th. So that would be the answer. Then let's go to problem 16. So x cubed minus 6x squared plus 4x minus 24. So factor out the common factor from the first two, which is x squared. That leaves you with what multiplied by x squared would be x cubed, would be x, and then negative 6. Negative 6 times x squared is negative 6x squared. So if you unmultiply those two things, then you get that. And then if you look at the next two terms, what's in common to those two? The number 4 goes into both of them. Now unmultiply 4 from those two terms. So if you take apart 4x, you'll have just x. If you take apart 24 and you take 4 out of it, you'll just have the negative 6. Now you're going to factor out the common factor from that, and that leaves you with x squared plus 4 in front of it, and then you have just only x minus 6 at the end of it, like that. So that's how you do number 16. And then number 17. Well, it's 12 o'clock p.m. on Tuesday, September 15th, which means that today is the big announcement for something new from Apple, like a new iPad or iPhone or something like that. So that's exciting. And here we are just stuck doing math. It's too bad. Now let's see. X cubed minus 36 minus 4x squared plus 9x. But when you work hard in school, then you'll earn plenty of money to be able to buy things that you want, right? Okay, and help people and do things that make the world a better place. So x cubed minus 36 minus 4x squared plus 9x. So first of all, let's put them in order. So x cubed minus 4x squared, and then plus 9x minus 36. Now, let's factor an x squared out of the first two, the first group. That'll leave you with 1x left minus 4. Then take out a 9 out of the second group. Then you'll be left with x minus 4. Then x minus 4 is in common, so let's put that outside. then the only thing left is x squared plus 9. So that's the answer to that one. Then let's try number 18. So number 18 is x squared minus 4x minus 45. X squared minus 4x minus 45. X squared minus 4x minus 45. And this one is just what I call regular factoring. It's really, really important. It's just a trinomial starting with x squared, has two terms after it. So what you do is you first look at the x squared. You can, of course, factor apart x squared into x times x, right? But now you have to look at the number at the end, 45, negative 45. You have to find the multiples of that, like 5 times 9, but you have to make the signs of them so that they will add up to equal the number in the middle. The number in the middle is negative 4. So if I use a positive 5 and a negative 9, then it will work. So if I put a positive 5 there and a negative 9 there, then that will be the answer. Then let's try number 19. Number 19 says 3x squared plus 9x minus 30. Now you have to find, if there's a common number, you have to take it out. And there's 3. So we have to take that out. And then we're left with that. And then now we leave the 3 on the outside, but we break the other part apart into two different factors. The x squared breaks apart into x times x. And then you look at the negative 10. Negative 10. You break that apart into 5 times negative 2, because 5 plus negative 2 would add up to make 3, which is the number in the middle of the problem. So we need to get the middle number. So it'll be positive 5, negative 2. And there we go. Then number 20. X to the 6th minus x to the 3rd minus 20. So first of all, we look at the x to the 6th. That can break apart into x cubed times x cubed. Then we look at the minus 20 and find numbers that will break that negative 20 down. We could pick something like 2 times 10, or 2 times negative 10, or 5 times 4, or whatever. So I'm going to pick, but it has to add up to equal what though? We'll look at the negative x cubed in the middle. That really technically has a negative 1 in front of it, right? So we need to make this be a negative 5 and a positive 4 so that it'll add up to negative 1. So it'll be a negative 5 and a positive 4. And then there we go. Now problem 21. So x to the 4th minus 3x squared minus 40. Well, once again, x to the 4th can break apart into x squared times x squared. And then you need to break the negative 40 apart into two numbers that multiply to equal itself. So negative 40 can break apart into like 1 times 40, 2 times 20, 4 times 10, 5 times 8. Okay, there we go. Because we have to change the pair of numbers so that it has a sign that adds up to be the middle number, which is negative 3. So if I do a negative 8 and a positive 5, then that would work. So I'm going to do a negative 8 and a positive 5. So there we go. Then we have problem 22. This one says 21r squared plus 23r plus 6. Now, if you look carefully at this, there is no number that you can factor out that's in common. So if there is no number in common, then you need to take the number at the beginning and the number at the end and multiply them together. So 21 times 6. So 20 times 6 is 120, plus 1 times 6 is 126. Then you need to break apart 126 so that it adds up to be the number in the middle, which is 23. So what two numbers equal, what two numbers would do that? So 126 breaks apart into 1 times 126, or it breaks apart into 3 times, no wait, hold on, I skipped one. It breaks apart into 2 times 63, or it breaks apart into 3 times 42, or it breaks apart into 7 times 18, or it breaks apart into 9 times 14. There we go. So see, 9 plus 14 adds up to be 23. So you pick that 9 and that 14, and you write the problem like this. 21r plus 9 plus 14. Now that's not finished yet, so that's not the final answer. You have to eliminate anything in common. Well, in the first factor, there's 3 in common. In the second factor, there's 7 in common. So that's going to leave you with 7r plus 3 and 3r plus 2. 3r plus 2. So there we go. That's the answer. Now we come to problem 23. $25a squared b plus 45ab minus 90b. Well, we have to factor out a common factor, which would be 5, I think. 5, yes. And then b. So if I do that, left is 5 times 5 makes 25, so 5 is left. A squared is left. 9 would be left, and a would be left. And 5 out of a 90 leaves you with an 18. And then the b is already gone, so I'm left with that. Then, now there's no other number in common, so now I have to take this 5 times the negative 18, which equals negative 50, negative 40, negative 90. And then I have to hunt for numbers that make negative 90. So I could do 1 times 90, 2 times 45, 3 times 30, 4, 5 times 18, 6 times 15. Okay, there it is, I think. No, yeah, there it is. So if now I can change the signs. So if I make the 6 be negative and the 15 be positive, then that will add up to make 9, which is what I want. So now I'll have 5b, and then I'll have 2 parentheses, and then I'll have the negative 6 and the positive 15, and then I'll have the 5a and the 5a in front of those. But then once again, just like I did in the last problem, I have to eliminate any common factors. So this one does not have anything in common in the first one, but in the second one, 5 is in common. So I have to eliminate that 5. So I'll be left with 5a minus 6, and then a plus 3. So that's the answer. Then problem 24. So 4x squared minus 25. This is really nice. So it says factor the difference of 2 squares. So you just take the square root of that term and get 2x. Take the square root of that term and get 5, but then you keep the sign between them. Then you use the same two terms again, but you have the opposite sign between them now. So you have 2x minus 5 times 2x plus 5, and then that's all. That's called the difference of two squares. Then problem 25, it says 64x squared minus 16x plus 1. It says factor any perfect square trinomials. What you do on this one is you take the square root of the first term, you get 8x. You keep the sign from the middle, just the sign, nothing else. And then you take the square root of the last term, the square root of 1 is 1. And then you put the perfect square on the outside. So the answer to that is parentheses 8x minus 1 squared. And that's the end of all your notes for your Chapter 5 test. And I hope and pray that you all do a wonderful, wonderful job on it. And thank you very much for your excellence in this class. Best wishes to you.